Okay, so today we are going to talk about isotonic solutions. So when we talk about isotonic solutions, they are solutions that are meant to be applied on our body membranes or in our body specifically. So when they are applied to our different body membranes, for example, sa aton nga mata, so sa aton nga mga dulungan, they should not give us damages or pending damages. Okay, so such as your cell lysis, cell dehydration, it could cause bleeding, di ba? If not correct ang aton yung mga concentration. So somehow, when we talk about isotonic solutions, you are going to prepare this in your lab. Maybe in the future, if you become manufacturing pharmacist, so you should be the one who's going to calculate the level of isotonicity, how many drugs or how many grams, I mean, of drugs should I add to this kind of solution or to this kind of vehicle in order for it to become isotonic. So next. So it should always be adjusted to approximately the same osmotic pressure as that of your body fluids. And guys, before everything else, your osmolarity and your tonicity should be defined or should be differentiated. When we talk about osmolarity and osmolality, we are talking about the number of molecules present in your solution. So, ano bala kadamo ang nag-dissociate ng sodium chloride sa akon nga solution. So overall, we are just calculating the dissociated particle with respective to the amount of your solution. So it's the same with your molality and osmolarity. We just added your I factor or si Van 't Hoff na to bala kung pila kabilog ba ni bala nga species ang ma-dissociate. So as you can see here, 1 osmol is equal to 1 molecule of that certain compound times n, where n is the number of species into which the solute is dissolved. When we talk about, for example, NaCl, if I have 1 molecule of my NaCl, usually, when I drop NaCl to my water, how many species will it become? Usually 2, di ba? Kay electrolyte sa. Excuse me. So therefore, your osmol is your 2 osmol. So compared, if you want to get the osmolarity, you just divide it to the liter of your solution. If you want to get the osmolality, just divide it with the kilogram of your solvent. And it's the same with the formula of your molality and your molarity. Okay, gin-multiply mo lang siya galing sa number of molecules or number of species that it will dissociate. So next, tonicity. These both terms are quite interchanged, di ba? So when we talk about tonicity, this is the comparison of your different osmotic pressure or osmotic solutions. So for example, when we talk about tonicity, there should always be the presence of your cell membrane or a boundary, a semi-permeable membrane, into which you are going to introduce one. This is the solution 1, for example, and this is your solution 2. Okay? So with your tonicity, this is just the comparison of, for example, of this solution that you've inserted to this solution. And when you separated them with the cell membrane, what happens to the water? Will it move inside? Will it move towards here? Or will it move towards here? Okay? So next, with your tonicity also, we are using the osmosis nga principle, into which the solvent movement ang aton ginastoryahan. It's always the water molecule that moves, diba? So the more concentration or solute concentration, the more nga mas makadto to ang tubig. The more nga jutay ang solute concentration, the more that the water will find somewhere that there's more sodium chloride solute concentration for it to dilute. So always remember, where sodium goes, water goes. So this is the difference. Again, when we talk about osmolarity, this is just the number of solute, okay, or the number of dissociated species to your liter of your solution. So how many osmol per liter are in your solution? When we talk about tonicity, you are just comparing the different solutions having osmolarity or having the concentrations divided by your permeable membrane. So, amula mo na siya, guys. So, your tonicity depends on the number of solute that does not move around. Because again, gani, what we are talking about in your tonicity is always your osmosis principle. This is the movement of your solvent. So as you can see, you can say that a certain solution is hypoosmotic if it has lower solute. Siyempre, jutay akong solute, jutay ang ma-dissociate da. You could say that this kind of solution is also hyperosmotic if it has more solute on it. Okay? So these terms here are the ones that we use to express your tonicity. So you are isotonic if, ano gani, equal imo solute, equal imo water. So let's take, for example, if you are hypertonic and you are in a blood vessel, this is the RBC. Anong matabo? Sorry, excuse. There's, when we talk about tonicity, guys, relationship ni siya sang duwa ka solution depending on their osmolarity level. So, for example, if you are hypertonic ang imo condition, CRBC ta, there is lower solute concentration inside of your salt, for example. And si plasma mo, tamaan kakaon mo gid sang panyaga sang damo-damo nga salt. So ano matabo? In relation to the concentration of your plasma to that of the liquid inside your RBC, your plasma is hypertonic because it's the one drawing out your water from the RBC, causing now your cell dehydration, okay, or your crenation. Next, we have hypotonic when we talk about the relationship of your plasma to that of your RBC, into which your plasma now contains little of your solute. So for example, sobra mo ka ihi, damo-damo sang sodium nga napagwa mo sa imo nga ihi. So ang natabo is that you have low solute concentration of your sodium inside your plasma, and your RBC now is the one containing more of the sodium. What happens is that the water in our plasma will be moving in of your cell. So now your plasma is hypotonic in relation to that of your RBC. So I hope we are clear with that. So now this will cause your cell swelling. Okay, alam mo na siya, guys. So na-drawing ko na siya nga daan before. So with your isotonic, there's no problem. That's why we would want isotonic, because if there is equal osmolarity between solutions, there is isotonicity because wala sang movement sang water, because parehas lang man. Hindi ta maghisaay. You have 0.1 molar there of your sodium. I have 0.1 molar of my sodium outside here. So wala ta problema. There is no cell lysis or cell dehydration. So are we clear with that? Hopefully, no? So next, we have the measurement of your tonicity, to which when we talk about measurement of tonicity, we're just going to say if this is isotonic or hypotonic, diba? So the first method is your hemolytic method. Of course, guys, before, sino man ang mga scientist being gulpiada lang pagbata siya, kabalo na siya sang formula, diba? So what we did before, sa ambot ano 19 ano na. So what we did before is of course the scientific method or your trial and error. Because you're curious, so of course you will do it. So maybe there were instances into which they formulated or nag-inom sila sa mga mushroom, nag-insert sila sa ilalawas ng kung ano-ano, and then there is reaction. So maybe they somehow speculated that this kind of concentration is not suitable sa aton lawas, diba? Stuff like that. So hemolytic method were used before to determine if it is isotonic, hypotonic, or basta mo na siya. So si hemolytic method, of course, by the word hemo, we used blood, specifically your RBC, to see if it lyses to certain concentration of your solutions. So thus, we are always using your RBC as an example for your isotonicity or your tonicity relationships, diba? So before, trial and error lang gid. Kung ma-add ko sang ammonica damo, malupok bala ang cell, diba? Or not. Next, we have also the colligative property, into which we use the vapor pressure lowering using controlled chambers. So ari, sang naka-recover na sila sang ato ni trial and error, and they used a more systematic way to measure if tonic man or isotonic man ang ato niya solution. So it's controlled in your lab. So they have their own chambers, thermal nga mga bulutangan, tapos kung ano da kadamo ang vapor pressure nga makuha, di ba? So, may standard man guys For example, kung ma-lower akong vapor pressure but by 2 degrees, it means that this is isotonic. So somehow, like that. Okay? Do pares man sa aton niya, freezing point depression niya. Okay? Or, wala labot, sila gini mga traditional tanga ginayusar. We are also using now what we call your L-iso value or what we call your level of isotonicity. So please read it on your Martin's physical pharmacy book on how we derived with this one. So I don't think that you need the derivation, but if you would want, if you're someone curious and you would want to know how we derive this one, then read the book. Okay? So amula ni siya guys. Si Liso ni panawag ko siya Li sa value. This is really one of the concepts that got my module 5 kind of low than my expected score because wala ko ni siya na-notice before. I do know how to calculate the tonicity via other methods, but not this one. So, ambot natabo sa ako na blackout core, wala lagi ko katuon. Okay? Now, when we talk about LISO value, and we would want to use it to measure the tonicity, we are actually relating it to your freezing point depression nga concept. Okay, ano to gani guys? If you add more solute to your water, what happens? The freezing point of your water becomes lower. Okay? Mas dugay magtiga ang tubig. So at 0 degrees lang dapat, but if you add something, ano gani matabo? It will become 0.06 negative, di ba? Negative 0.06, mas manubo ang atong freezing point. So basically, your LISO value is just your KF. Sakto? Si K, di nang gani si KF man, siya ning aton freezing point depression constant, right? Freezing point depression constant. So, ayagi ko guys, sorry good guys. So, usually, anong nadumduman nyo? This is your water, which is your 1.86 Celsius per molal. Diba? Pero kalimitan ta na ito siya guys. Nga, ginabutan ko na siya para ma-appreciate nyo. So, si L ni, this is your LISO. Actually, this is your LISO. This is just your KF together now with your I. Sorry, law ay ako na. Together now with your I. Magsiling ka sang I, ano to siya gani? Abi ko, miss, amo na tong last ko nga makita sa mga colligative properties, may amo pag gini. This is your Van 't Hoff factor or your I factor. So how many molecules or how many species will it dissociate? Do sa osmol taman to ginastoryahan. So therefore, your L here is just your freezing point depression constant. So at a certain concentration, okay, and it's Van 't Hoff factor. Okay? So miss, ti paano tani usaron? Ginausar tani siya. So usually your LISO is just constant. It is given to almost all of your compounds or electrolytes or non-electrolytes. May table tada karon. Are? Okay? So each class of electrolytes has certain LISO value. So somehow you don't need to calculate for it. But I'm just letting you know kung anong purpose. Yeah. So therefore, anong purpose ani nga ginastoryahan ta sa LISO? So if you do have the LISO value, the level of isotonicity of a certain electrolyte and its concentration, okay, isotonic concentration of that certain electrolyte, it means that a certain electrolyte has a certain concentration para mangin isotonic siya sa aton lawas, di ba? So si LISO tag si isotonic electrolyte concentration, actually molarity na diyang ginagamit ta. So sa freezing point tayo before molality. In here, we are just dependent on the amount of your solution. So it's always liter of solution that we are talking about. So if you're given the LISO and the isotonic concentration, you will now have the change in your TF. And guys, always remember that a certain isotonic solution always have a freezing point or always has, wrong grammar, always has a freezing point of 0.52 degrees Celsius. So guys, if gingaan ka liso, kay di ba may lista ka naman lang sa laboratory, muna siyang liso ni amo ko ni, tapos amo ning iyang solution, nagtimpla ka dabi. 1 gram of sodium propionate to 100 ml of water. So you have now 1 gram or 1% of your sodium propionate. And then you multiplied it to the level of isotonicity, the constant that you should have here. And then, pag multiply mo, ang natabo is the change of TF mo is, anong nakuha mo? You just got, for example, 0.44 degrees Celsius. So ano nang gina-indicate niya? It is indicating that your solution is still not isotonic. You are still hypotonic because lower ka sa 0.52. Diba? Or, I mean, lower ka sa imo nga 0.52. So you're still hypotonic. You still need another 0.08 degrees Celsius to reach your 0.52. So ano himuon mo? Of course, add ko a little bit sa akong 1 gram per 100 ml para malabot ko ang 0.52 degrees Celsius na change in TF. Diba? Kaya ang aton yan standard, guys, is always your 0 degrees Celsius. So I hope we are clear with that. So we are using your LISO value in order for us to get the change in your temperature. And basically, we would want a certain change in your temperature to reach 0.52 because 0.52 is always your standard. Okay? And this one here below, this is just how you derive certain LISO value for your different electrolytes. But what we've shown here is actually just the LISO value or how we derive the LISO value of our standard, which is your sodium chloride. So guys, the LISO value for a 0.90% solution of your sodium chloride, which has a depression point of 0.52, is thus isotonic with body fluid. It is actually 3.4. So si LISO ta guys. Okay? So ambot hindi ko na lang guro pag ano, but LISO, sorry. L-iso is equal to change of TF, which is your 0.52 degrees Celsius, over the concentration, which is your 0.1.4 m, that would be your 3.4. And guys nga, mo niging gamit ta, because always, 0.90% of your 0.90% of your NaCl is always our constant when we talk about isotonic solution. It means that any compound converted to 0.90% NaCl equivalent will always be isotonic to our bodily fluids. So si LISO ta, it can be derived also from your different electrolytes, given nga ang concentration ni ginhatag sa imo is isotonic. And you always have the standard, which is your 0.52 degrees Celsius. So diri guys, derivation na ni siya kung paano ginkuha ang imo nga LISO. But this is the application on how to maneuver or how to measure or how to conclude nga ay isotonic na ko, ay hindi pa ko isotonic. Okay? And your LISO value is used for sodium chloride equivalent in the future. So we'll proceed para makita nyo. So si LISO ta, important din siya. So we have different kinds of method on how to adjust now your tonicity. Ato yung guys, kina-measure ko pa lang. Ginahambal ko pa lang sa self ko nga, ay, 0.44 pa lang ako nalabot. I still need to have my another 0.08 degrees Celsius. So what should I do with my concentration? You need now the different methods to adjust your tonicity. So ano ba lang himuon ko gamiton ko? Nibala si cryoscopic method? Should I use the sodium chloride method or should I use the class 2 methods? So guys, mind you, it always goes out in your board exam. So cryoscopic method, you are using your 0.52 degrees Celsius as your standard. So always ga-freeze ang aton nga tears, aton blood, aton ihi. Hindi man ihi guys kay ang ihi ta may mga iban-iban. Aton nga aqueous humor, aton cerebrospinal fluid. They are almost or they are freezing at 0.52. Do ka namin testingan no, dupla kada bi kag ibutang sa ref kag lantawon ta ko maglabot 0.52. Yeah. Okay, so na siya. Sperm, okay? And number two, sodium chloride equivalent method is when you are going to get the equivalent or how many sodium chloride is equivalent to a certain compound. Or for example, may 1 gram ko sang boric acid. Pila bala ka milligram or grams ang boric acid ang akon i-add para equivalent siya sa sodium chloride. Kaya ang akon yan standard is 0.9% lang. Di ba? So we'll know later. Next, we have class 2 method into which ang gakatabo diya is you add more of your water and not is you add a certain drug to water. So you will make first a solution that is quite compatible para mangin isotonic. So how many water should I add to this amount of drug for it to become isotonic? And then if I would want to make 100 ml of that drug, how many pagid nga isotonic solution na lang i-add ko para ma-dilute ni? Okay, so let's have the problems para maintindihan. So, to ako an example gina. So now, this is how you derive what we call your sodium chloride equivalent. Ano to ganyan ba ko gina nga tandaan nyo kay Liso? Si L-isot tanaw is here. Okay? So it means that if you have been given with an L-iso sa inyo board exam, for example, hydromorphone has an L-iso of 1.4. Find its E equivalent or sodium chloride equivalent. Guys, walang kakapoy-kapoy. Just memorize this formula. E is equal to 17. L-iso, which is the 1.4. And now the molecular weight of your hydromorphone. And usually you are given the molecular weight. So for example, hydromorphone would be 100, example ni guys, hindi exact, would be 186 gram per mole. Then, times 17, that would be the value for your E. So, ambot pila ni siya. So, let's have calculator. So, butang ta lang guys, estimate na lang kay kakapoy type. Butang ta 2.0.6 or 0.5. So, your E value is 0.5. So, it means that dapat guys, kabalo ka mo mag-express. So, arin na lang gali guys, no? Example. So, calculate the approximate E value for ephedrine sulfate. So, as you can see, it is given. We just substituted it. And we have now the 0.23. So, anong himuon ta? When we talk about sodium chloride equivalent, literally, equivalent. Pila ang equivalent ng sodium chloride if may amo ko ni nga kadamuon sang akon ephedrine. Okay? So, ang matabo ni, maghambal ka sang E-value, this is how you interpret it or this is its unit. You have 0.23 grams of NaCl in every 1 gram of my ephedrine sulfate. Para hindi gamo aton kabuhi in the future. Sa aton yung mga calculation. Guys, gets lang? It is sodium chloride equivalent because you converted the amount of your ephedrine sulfate to that of your NaCl. Okay? Kaya para gani mga isotonic ta because our standard is the 0.9% sodium chloride. So we are always converting our different drugs, the ephedrine or ano pang mga gamiton ta sa future, into your NaCl value. Okay? Para hapo sa aton mag-calculate sang isotonic because we are always referring to the standard, the 0.9%, para hapo sa aton kabuhi. So, maski ano pa nga drug ang ihatag si imo, aspirin, ephedrine, propionate, or whatever, they are all converted into the E value or its sodium chloride equivalent for us to have an easier standard. I hope that is clear with you. So, this is now the purpose of your L-iso. So, don't worry, your L-iso is usually given. I've just shown you how to derive it and what is its purpose, diba, sa aton nga calculation above. So, pero ang pinaka main purpose, sige guys, sa aton laboratory is for you to substitute it sa aton nga formula nga ini para sa aton different kind of drugs in order for you to get its sodium chloride value. So again, in every 0.23 grams of your NaCl, there is 1 gram of ephedrine sulfate. So you could use this value, E values, for the future calculations that you will be seeing later. Miss, dinihalin si 17. Your 17 is actually derived from the molecular weight of my NaCl and my L-iso value of NaCl, which is 3.4. And I guess molecular weight of NaCl was about 58, I think. So it's somewhat there. So gin-divide si 58 by 3.4 according to the derivation sa aton book. Okay, so kung paano siya na-derive. But somehow, this is how it works. And this is not the only way. So miss, kung wala ko yung gan L-iso value, paano na? Then, you go the long route. So we have the 58.8 over 1.8. Let me check, guys, kung 3.4 gid man si NaCl. Check to, guys. So 58 over 1.8 over molecular weight over I. So just memorize this one. These are just values that are really constant. So, mula mo na siya. What else? So, amo na kayo sa, if you're not given L-iso, just use the other one here. So, next. Again, no need for you to solve it or derive the L-iso. It's either gaan ka mo problem nga may L-iso and the concentration, and then you will solve for the change on TF, and then you have to conclude if it is hypertonic or hypotonic, diba? So, these are all your different L-iso. Okay? So, memorize the values as much as possible. So next, let's proceed now. So we have now the class 1 method, your cryoscopic, and your NaCl equivalent method. So, medyo blur pa itong pang wakal ko ano itong mga i-value ni Miss Man, kagliso value ni Miss Man. So, with this one, we're going to apply it para hapos na lang sa aton. So, let's start. Problem number 1, how many milligrams of NaCl and dibutane HCl are required to prepare 30 ml of a 1% solution of dibutane HCl, which has the change in TF. Hindi ko ba lumag-insert triangle, guys, sa kanya PowerPoint, which is isotonic now with tears. So it is a cryoscopic method because we are depending on the freezing point depression of your sodium chloride or your isotonic sodium chloride solution, which is again your 0.52. So guys, step 1. Step 1 is to compare it to your 0.52 degrees Celsius. And anong hambali, guys? I have 1% of dibutane HCl. So si 1% ko na solution of my dibutane HCl produces a change in TF of 0.08 degrees Celsius. Guys, ang atong standard is water. So kung nag-add ko 1% kuno sa akon water, anong matabo? There is now depression to 0.08 degrees Celsius. Gets? So anong matabo? Puno, hala 0.08 pa lang gidya ang akon na depress sa 1% kay dibutane HCl. Kulang. Kulang pa katama ang akon solute in order for me to reach 0.52. So, anong i-add ko? Of course, NaCl because this is always your standard. So, anong himuon ko? Of course, i-minus mo na anay sa 0.08 degrees Celsius, that would be equal to 0.44 degrees Celsius. It means that, anong ginanamin niya, guys? I need to drop my freezing point to another 0.44 degrees Celsius. Because it is given already that the 1% solution of my dibutane gives a depression of 0.08 from the 0, which is the standard. So, kinailangan ko pagid another 0.44 degrees Celsius. Diba? Understood? Next. Step 2. Para hapos. Step 2 is that you get first the whole sodium chloride that you would be needing for your solution. So, calculate for NaCl needed for the whole volume. Okay guys, sino gani ato na naman yung standard? It is your 0.9% sodium chloride. Okay? So, amo ni aton nga mga NSS bala, natural saline solution. That would be 0.9% NaCl. So it means that if you have 0.9%, it means that you have 0.9 grams of NaCl over 100 ml of your solution. Alright? So now, anong gusto ko matabo? Gusto ko mabalaan kung ano kadamo ang akon mahimo or pila kabilog nga, how many NaCl or how many grams of my NaCl is needed if I only want, ano ganing gusto ko i-prepare? If I only want 30 ml. Guys, application of your pharmaceutical calculation. But with a twist and kind of complicated if you don't understand it. So guys, what would be the answer? That would be 30 times 0.9 x gram of my NaCl for the whole. That would be equal to 0.27 grams of NaCl, right? So it means that my 30 ml needs 0.27 gram of NaCl in order for it to become isotonic. Okay, to become isotonic. So now, si 0.27 grams ko, it represents now my whole volume. So my whole volume is now represented. The 0.27 gram NaCl ko, it represents the whole solution that is isotonic. Therefore, it has, ang normal lang dito guys ha. So kung 0.27 grams ang NaCl ko out of 30 ml of my water, it means that this is already isotonic. Kaya compare ko man lang siya, reduce ko man lang siya. So it means that this solution freezes at 0.52. Kumbaga siya ng IMO standard. Gin-reduce na lang IMO standard into 30 ml. Okay, right? So now, what should we do? Since 0.52 IMO standard, pila gani ang atong step 1? Hambal ta, kinlanlan ta pila nga amount sang NaCl sa aton nga 0.44 degrees Celsius. So ratio and proportion lang siya guys. 0.44 degrees Celsius. So what would be the grams of my NaCl that I still need to add? So that would be equal to 0.228, right? Or ano ginapamangkot sa aton? NaCl. Or what we are being asked is the milligram. So we have 228 milligram of NaCl that would be added to your whole solution. But ano gani guys ang pamangkot sa imo? Pila ka milligram si NaCl kag si dibutane. Of course guys, dibutane mo is 1% of your 30 ml. Therefore, this is, may answer na ta guys sa NaCl. So for your step 4, actually, hindi naman siya guys step 4 kay ka-given na siya katama. 1% of your 2 ml would be 0.3 grams of my dibutane. So, given na siya guys. Because kung gani ang 1% ko, ginpadrap ya 0.08. So, ang ginpangita na lang ang 0.44 or how many sodium chloride that we will be adding in order for us to achieve the 0.44 degrees Celsius. So, given na iya, constant lang si 0.3 grams of your dibutane. And this is now your 1%. So if we convert this to milligram, that would be 300 milligram of my dibutane. So guys, if you would want to make an isotonic solution at 30 ml, you add 300 milligram, step 5. You add 300 milligram plus 228 milligram of NaCl, or dibutane, into your 30 ml water. Then you're good to go. Pwede mo na ni siya ipatulo kung diin da nga gusto mo. So maybe, since this is dibutane, this is a painkiller or a local anesthetic. Therefore, this is now safe for your body membrane or cell membrane. I hope you are clear with this one. Okay, let's proceed. We'll have now the calculation for your sodium chloride equivalent. Guys, for your sodium chloride equivalent, sorry, medyo gawda ko ito. For your second method, which is your sodium chloride equivalent, ang ginpang solve ta gina guys nga e-value, amo na ni siya. This is our derived e-values. So kung naghatag ya sa board exam mo yang from scratch gid ya guys nga ikaw gid ma-solve sang e-value ni phenacane, ni chlorobutanol, amo to danay nga process ang imo gamiton. Sorry. What we call the e-values that we have derived from the L-iso or the other formula that we've seen. So it is called the sodium chloride equivalent method because we are going to make use of them in order for us to convert these different drugs to their sodium chloride equivalents. In order for us to get the right amount of the certain drugs nga inug dilute ra. Okay? So let's have step 1. Oh, I don't have the... Okay, sige. Step 1. Wala ko extra area to write on. So gamayon ko lang. So for step 1, po, sana si Sia, wait. Okay. First step 1, guys, is to actually convert all of the given, all of the given ingredients with amount to their sodium chloride equivalent. So as you can see here, your phenacane is one of your drug, and it says that it is in 1% concentration and 0.5% concentration si chlorobutanol mo to a 60 ml nga solution. So gusto ko maghimo 60 ml nga solution and I have 1% of it, di ba? And I have 0.5% of my chlorobutanol. But how about my boric acid? Pila ni siya ayhan ang indog add ko sa iya, di ba? Para mangin isotonic ang bilog nga solution. So this is just again basic pharmaceutical calculation but somehow with a twist again. So guys, first anong himuon ta is to get the grams of the substances. You convert the grams of substances. Get grams of your substances. And then, karon lang ta ma-convert or, okay, and convert them to their NaCl value. So what we should do, guys, since it is 1%, ano ganing magsiling ka 1%? You have 1 gram of phenacane over 100 ml of solution. Application na siya, guys, sa mga weight per volume ta. So, since I would be making 60 ml, pila na lang ang akon grams. Pila ko ka grams. Diba? So, amo na siyang matabo. Same with this one, with your chlorobutanol. 0.5%, so I have about 0.5 grams over 100 ml. So, how many grams do I have over 60 ml, right? And the answer here would be about 0.6, I guess. Okay, 0.6. 0.6 grams. And the other one here would be 60 times 0.5 divided by 100. That would be 0.3 grams. So are we done here? Not yet. We have now the grams of your substances out of your 60 ml. But, miss, ano na siyang purpose ni E? Again, this is now your 0.20 grams of NaCl over 1 gram of my phenacane. Same to that of your chlorobutanol. This is again 0.24 grams of NaCl over 1 gram of chlorobutanol. Para makita nyo, guys. So, anong matabo? If I multiply my E value, which is 0.20, on this one, anong matabo? Ma-cancel out ang gram ni phenacane, kag ang gram yung 1 gram below, you will just be left with the gram of NaCl. Therefore, the value that we are going to derive here would just be the NaCl equivalent. This is the NaCl equivalent of your phenacane. That is 1% to your 60 ml. So I hope it's clear. So 0.20 times 0.6, that would be equal to 0.12. 0.12 grams of NaCl. So guys, ang basically ginahimo ta, ga-derive ta sang grams sa NaCl. On the other hand, it's still the same. 0.3 grams times the 0.24. So again, anong matabo? Ma-cancel out ang grams ni chlorobutanol. Kag ma-cancel out ang 1 gram ya below, you will just be left with 0.3 times 0.24, which is now your 0.072 grams of NaCl. Grams of NaCl. Okay, are we good with that? Yes. So now this is your step 1. Your step 1 is to get the grams of your substances and to convert them into NaCl value. Okay, step 2 now would be, step 2 is to add both values from your step 1, which is the 0.12 grams of NaCl plus the 0.0072 of your NaCl. So you have now the total of 0.192 grams of NaCl. So it means that you need to add 0.192 grams of NaCl, equivalent na siya sa 0.6 gram kag 0.3 grams ni phenacane kag ni chlorobutanol. Kay equivalent sila gani. So next is step 3. For your step 3, so I think we did this on the other side. It's when your in your step 3, we just have to derive the whole sodium chloride that we will be needing for your 60 ml. So again, sila ganing standard ta, the 0.9% NaCl over 100 ml. And pila lang gusto ko himuon? 60 ml lang, guys. So, pila ka NaCl ang kinahanglan ko overall sa 60 ml? That would be 0.54 gram of my NaCl required. So, tanan-tanan nga gusto ko himuon should be or should have 0.54 gram of NaCl in order for me to conclude that the 60 ml is isotonic. So, 60 ml with 0.54 grams is isotonic. So now, ano ganing ginapamangkot liwat? How many grams of boric acid should I use? Diba? So let's go to your step 4. In your step 4, since I already have the total NaCl I've been needing for the 60 ml, which is 0.54 gram, what should I do is to, of course, subtract the amount of NaCl exerted by phenacane and chlorobutanol. It makes sense, right? Because ang bilinda should be the amount equivalent to your boric acid, right? Okay. So 0.54 grams minus 0.192 grams of NaCl. That would be equal to, 0.348. Hopefully nga kamo mismo ga calculate man. Of NaCl. Okay? For boric acid. Okay? For boric acid. So kung ikaw guys mag-interpret, ginkwa ko ang tanan-tanan yung equivalent ni phenacane kag chlorobutanol, convert ko sila sa NaCl kay because si NaCl always ang standard. Nakuha ko na ang ilang nga sum nga duwa, tapos ginkwa ko man ang kabilugan nga asin para sa 60 ml. Syempre, I will just subtract the amount of these two drug or these two sodium chloride equivalent in order for me to get the remaining nga inugad nga NaCl. So this remaining is for my boric acid value because si boric acid mo QS and is unknown. Therefore, what should we do? Should we just stop here? Of course, guys, hindi mag-stop because ang ginapamangkot si mo yan, hindi sodium chloride but rather boric acid. We just converted everything into sodium chloride in order for us to stick to the standard and for us to not get lost. Okay, so for step 5, this is now the remaining sodium chloride that you still need to add. QS gani ho, di ba? So now, we have to convert the value of your sodium chloride to your boric acid. So, ang matabo na naman niya, suli. Di ba? Hindi tayo mag-cancel out. What we should do is for the remaining 348 grams of NaCl to be converted to your boric acid times, divided by, divide guys ambot lang kaigo pa ni. Divided by 0.52 grams, guys. Again, do not forget the unit. Grams of NaCl over 1 gram of boric acid. So ano matabo, guys? You will cancel this out, and you will be left with the boric acid unit. Therefore, this is the amount of boric acid that you will be needing to add to the solution in order for you to have an isotonic solution. So 0.348 divided by 0.52 would be how much? 0.52, gid man na, okay. Yeah, right. Would be 0.67 grams of boric acid. So guys, amo lang mo na siya magkuha. So if you want to convert a certain drug to NaCl, just multiply it because there will be cancellation. If you would want your NaCl value to be converted to a certain drug value, just divide it to its E value. Diba? Hapos lang. So it's either you multiply it or you divide depending on what you want. Okay, so I hope you will have the time to internalize this calculation part. And next, you will have your class 2 methods. Guys, your class 2 is not that complicated. Why is it? Because you'll just have the formula here. Amo na ni siyang formula and okay na ang tanan. So the moment that you will derive the volume of your water, okay, you will just subtract the volume of your pure water to that of the needed isotonic solution amount, and then that's the amount of isotonic solution that you will be using. Again, for class 2 methods, guys, what we are doing is for you to dilute the drug into a water in order for them to become isotonic. At the same time, if you would want to make 50 ml, for example, tapos ang pure water kag drug mo, combine mo sila together, tapos do 10 ml lang imo nakuha, then you will just add another 40 ml of your isotonic solution para ma-reach ang ina nga volume sang isotonic solution. But you now have the desired amount of drug that you will be needing with this kind of methods. Syempre, may example naman ta. Para kabalota. So guys, I will show you the long method on how to solve this one para ma-appreciate ta. And I will show you also the application na sang shortcut ta. Okay? So for the second problem, determine the volume of purified water and 0.9% weight by volume sodium chloride solution needed to prepare 20 ml of a 1% weight per volume solution of your hydromorphone, which has now the 0.22 E value. Okay, so now let's start. Step 1 again. Kung gusto talong method, guys. Step 1 again here is for you to get the substance or the amount of substance and then convert it to its sodium chloride equivalent. So as you can see, wala siya yung naka-tabular form or naka-RX form. Anong himuon ta? Based sa pagbasa mo, gusto ko mag-prepare sang 20 ml of 1% hydromorphone. Again, you have 1 gram of my hydromorphone over 100 ml of my water or 100 ml of your solution. So, if gusto ko niya maghimo 20 ml, pila gid ka hydromorphone ang kinahanglan ko, di ba? So, X gram of my hydromorphone, pila? That would be 20 divided by 100. That would be 0.2 grams of my hydromorphone times now the E value, which is 0.22 gram of NaCl over 1 gram of hydromorphone. Amo ko na guys magsulat sang E value para madumduman ko nga ang gina-cancel out ko ni nga amo ni ginagamit. So 0.2 times 0.22, that would be okay 0.044 grams of my NaCl. Okay, so we're good with that. Next, step 2, guys. Step 2 again is to get the total. For step 2, gali guys, we are going to get the amount of the purified water or the amount of water that we will be needing for our problem. Diba? So, ato na naman standard, again, would be 0.9 over 100 ml. And since you're given now, with the 0.04 gram NaCl, amo ni siya gina-exert ni 1% sa aton, ni 1% of hydromorphone sa aton 20 ml. So what we will be doing is to get the volume of your water, which is now your, guys, sa aton yung mga isotonic problem, usually hindi ta specific sa solvent or solution as long as sakto lang ang kalamuon sa aton yung mga salts. Okay? So 0.044 gram NaCl, ratio and proportion again. So the X ml of your water, this would be equal to, I guess, pila? 4.89 ml. It means that I still need to dilute the 0.4 gram, the 1% hydromorphone to my 4.89 ml. Okay? So pilang 1% ka 20, guys, that would be 0.2 grams, right? So I would need my 0.2 grams of hydromorphone to be diluted to my 4.89 water for me to have the isotonic solution. But guys, imagine na, 4.89 ml ka pa lang sa tubig. Anong galing gusto mo mahimo? You need to make 20 ml. So this is now where it enters, this formula. So ang gusto ko matabo, step 3, pila ganing kinahanglan ko? I want 20 ml of water. Sorry. Amo panigiling X. The volume of my isotonic solution is still the one I would want to have. So the volume that I'll be needing is 20 ml. The BRX, amo ni siyang recommended, amo ni siyang prescribed ko nga kinahanglan, minus ang tubig, volume of water that I have derived, which is 4.89 ml. Therefore, 20 minus 4.81 would be 15.11 ml of isotonic solution. So it means, guys, ginanamin niya nga, ang ginanamin niya di is, kinahanglan ko tubig na inog-dilute sa 0.2 grams ko, 4.89. But since isotonic na sila, hindi ko na sila gusto gubon. So what I will do is just add more of my isotonic solution, usually your NaCl 0.9%, which is 15.11, para lang makalabot ko sa 20 ml nga ginatawag. So in here, it's just ratio and proportion again. Diba? As you can see. So this is the long method if you would want to look at it. But if we use the formula of your White Vincent, hapos ang kabuhi, which is, ito gani, volume of water is equal to W times E times 111. Okay. So guys, where do you think did you get the 111? Your 111 is derived from 100 ml divided by 0.9. 100 ml times 0.9. So, kumbaga, amo ni siya ang conversion talang gingamit for step 2. Kaya di ba cross multiply ka? So, as you can see, 0.9x, di ba? Times 100 times, 100 divided by 0.4. I-divide man siya dapon dayon sa aton nga 0.9. Okay? So, 0.9x para makuha aton x. So, therefore, this 111 is derived from this formula. So, it's still for with the standard of your NaCl, the 0.9%. So, guys, ari na, hapos na ning kabuhi. Weight of the drug for me to get the volume of my water. What is the weight of my drug? It is 0.2 grams kay tungod nga 1% of my 20 ml. So, hindi mo na kinahanglan i-amo-amo ni pagtulok mo pa lang 1% of 20 ml. Laban-laban, 0.2 na siya. So if you would want, again, to go through kind of exhausting way na naman, so para hindi ka confused, 1 gram na naman over 100 ml kay 1% is equal, i-equate mo naman siya kung pila kung 20 ml, that would be the weight of your drug. That would be 0.2 grams of your hydromorphone times pilang ginhatag mo? 0.22. And you relate it now to your 111.1, which is din tani siya nakuha, gani guys, liwat, sa aton niya, 100 ml 0.9 or sa aton step 2. And if you look at it, this shortcut is everything that we've done here from step 1 to step 2. So, ariya gin isa-isa ta lang para ma-cancel out tani, para makuha ta si sodium chloride, tapos i-ratio ta si sodium chloride para makuha ang water. So, this one is the direct way to do it para wala ka na sang damo pa nga plotting. So, I guess, input it. 0.2 times 0.22 times 111.1, that would be 4.89 guys. 4.89 ml of your water. And then you just proceed to your step 3 again in order for you to get the remaining amount of isotonic solution that you will be using for you to dilute. So I hope everything's clear with this one. So that would be it for our isotonic solution topic. So thank you for listening.